takes it to the uterus where it fertilizes the ovum.
Yes, sir.
So without force, we can say life cannot exist. So force is a very fundamental part of the existence of life on the planet Earth.
Okay.
Okay. So every phenomena that we do is associated with some sort of force, like walking, eating, even while sleeping, a force is acting there.
Okay.
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 So force can be found in every phenomena that is happening around us.
Okay, sir.
Got it?
Yes, sir.
Okay. So take a look at the content. In this chapter, we will be discussing about force, what is force, the interaction of the different forces, what
Okay.
is the magnitude of the force, and what is the direction of it.
Okay.
We will
Okay,
be
sir.
also taking a look at a state of motion and rest, and what are the contact and non-contact forces.
Okay, sir.
Later on, when we will be done with force, we will talk about pressure.
Okay.
What are the pressure exerted by liquid, gas, and atmosphere?
Okay, sir.
Okay, so that's a rough idea of what are the things which we will be covering in this chapter.
Okay, sir.
Okay, so force, you have a rough idea of what force is.
Yes, sir. Yes, sir.
In the next figure, here you can see pressure. So pressure is what? In general language, day-to-day language, we talk about pressure. Say the blood pressure of this person has risen up. I have
Yes,
too
sir.
much exam pressure on me.
Yes, sir.
Yeah. So in the first figure, you can see blood pressure. This is blood pressure.
Okay.
In the second figure, you can see a person is lifting this heavy chunk of a stone.
Yes, sir.
In the third figure, the basically what is happening in the first and the second figure, it is being summarized by this description that when a force acts over a given area, over a unit area, that is
Okay.
called pressure.
Okay.
Okay.
Okay, sir.
So when we will come to that part, that is pressure, we will discuss in detail. So
Okay,
as
sir.
of now, let's talk about force. So before you talk about force, there's two things you need to consider while discussion of force.
Okay.
First one is rest and motion.
Okay.
So when a body is said to be in rest, look, when an object does not change its position with time, then the object is said to be in rest. Okay, so
Okay.
let's say there is an object over here. Let's say there is an object over here. Okay, at time 5 p.m. Okay, even after 1 hour, that is 6 p.m., if the object continues to be at the same place, it doesn't move away from its initial state, initial
Okay.
position, then we say that with respect to time, the object remain at its initial position.
Okay.
That is, the object is not changing its position, although the time is passing by,
Yes.
but the object tends to remain at its initial position. Getting it?
Okay. Yes, sir. So basically, if an
Getting it,
object
Abu?
or thing, yes, sir. Basically, if an object or thing stays in the same positions with the time passes on, then the object is called as it is resting, right?
Exactly.
Does it?
Exactly.
Okay. Okay.
Okay. So now consider a second case that at 6 p.m. this object was lying over here
Okay.
at position A.
Yes.
Now when the clock ticked 6 p.m., the object changed its position to position B.
Okay.
Then in this case, we will say that the object has done motion. Okay.
Yes.
So the definition of it is when the object changes its position with time, it is said to be in motion.
Okay.
See how the time change with respect to the change of time also, the position also changes here.
Okay.
So then the object is said to be in motion. So
Okay.
far clear?
So, sir, if an object is moving as the time passes on, so the object is called as
It is
it
in
is
motion.
having motion. It is in motion. Okay.
Yeah. Like a car. Take example of a car.
Yes, sir.
Let's
Right.
take example of a school bus. So when it is passing by, the time is also passing, the position is also changing. Now
Okay.
talking about force. In the above two figure here, you can see a man is trying to push a cupboard, and in the next figure, a boy is trying to pull this stone towards himself. Okay. So what do we infer from this? That force is defined as push or pull. Is defined as push or pull that causes change in body's state of rest and motion. Okay. So if the body, am I audible?
Yes, sir, you're
Okay. Yeah. So I'm saying that force is defined as push or pull that causes change in body's state of rest or motion. So let's say
okay.
this cupboard here is at rest.
Okay.
This cupboard over here is initially it was at rest.
Okay.
So this boy started pushing this. So what will happen if the push force is big enough, it is large, then this cupboard will move here towards this direction.
Yes, sir.
In the direction of the force, it will move. Okay. Or let's say a car is moving at a very fast speed.
Okay.
Okay. And from the another direction, a a big truck came and struck it.
Okay.
So this big truck also applied some sort of force on the moving car.
Okay.
So it eventually they both collided and it led to this car stopping.
Yes, sir.
Okay, they both will collide and this car will stop.
Okay.
So we see that force can be used to either change the state of rest or either change the state of motion. If an object is at rest, we can bring it in motion, or if the object is in motion, we can bring it to rest.
Okay.
Clear?
Yes, sir.
Okay, very good. So in simple terms, it is a push or a pull on an object that takes place when two objects meet or interact. Right.
Yeah.
So here, this man or this cupboard, they two are interacting with each other.
Yes, sir.
Right. They both are in contact. They are interacting with each other. And in this case, the man is pushing the cupboard. In the second case also, this boy and this stone, they are interacting with each other. They are in contact.
Yes, sir.
So here the boy is pulling the stone towards itself. So in
Okay.
simple terms, we say that force is nothing but it is push or pull. Okay, and when this will happen? When the two objects will meet together.
So push or a pull is called force, sir.
Exactly. In simple terms, we can define it as a push or a pull.
Okay, sir.
Okay. Got it?
Got it. Yes, sir. Got it.
Okay. Okay. So talking about force, let's discuss few more things about it.
Okay. Okay.
So push can be defined as a force which is responsible for movement of an object from a state of rest. Okay. See here in the figure, this object is at rest. A force is applied on it and it is started to move. So such a force which brings a change in the position of the rest of an object, that force is called a push force.
Uh,
And the important thing to consider about it is the direction of the movement. See, the
okay.
direction of the movement is, this is the direction of the movement and this
Yes.
is the direction of the force. So they both are in the same direction, right?
Yes, sir.
They're not opposite to each other.
Yes, sir.
They are in the same direction. So in a push force, the direction of the force and the direction of the movement, they both will be in same direction. Got it, Abu?
Sir, just please explain this push force once again.
Okay. Okay, just a minute. Yeah. Look, what is happening over here? Like in the case, in the figure which we saw earlier, this man is trying to push this cupboard.
Yes.
See over here, this is the direction of the pushing force, and the
Sir, just a
cupboard will
second.
obviously,
There's
it will
someone
move
on the
towards
door.
this direction. Okay, check
Yes.
that.
Yes, sir. Oh, sorry.
Yeah. So we were talking about push force. So push can be defined as the force which is responsible for movement of an object from a state of rest. Okay. Look, basically in push force, like here I have taken few examples of this push force, like kicking a ball, walking,
Okay.
closing a drawer, pushing a box. So basically you are doing a forward motion.
Yes, right.
You're doing a forward motion. You're trying to
Yes,
change the position of the object by applying a forward motion. And the
yes, sir.
movement also takes place in the forward direction. Okay.
Yes, sir. Got it.
So that is push force. So here are some
Okay.
examples like kicking a ball or walking, okay, or closing a drawer or pushing a box. These are the examples of a push force.
Okay.
Okay. Here's a stationary ball. You basically kicked it.
Yes.
You basically kicked it. You applied force and direction. So the ball will went away in this direction. Okay. So these are kind of push force. I'm talking
Okay.
about pull force. So what happens when we apply force in a direction towards us? We are
Okay.
pulling the object towards us, and such a force is called pulling force. Like in the
Okay.
figure, you can see this
Yes.
boy is basically he is doing what? He is pulling the car towards himself. Right? There's a car, and look at the direction of the force. He is applying that force over here, and the direction of the motion will also be towards the boy. Hello.
Yes, sir. Yes, I understand.
Yeah. So you see, he is basically applying force. That is, he's applying a pull force towards himself. He
Yes,
is
sir.
he is trying to bring the trying to pull the cart towards himself.
Yes, sir.
So you see, there are two things to consider over here. The direction of the force is towards boy, and
Yes,
where
sir.
will this cart move? It will also move towards the boy.
Move towards the boy.
Okay. While in the case of the push direction, both force and movement they are in the same direction.
Yes,
You
sir.
see what is I'm trying to say? Force is applied over here, and the movement is also in this direction. Here also, what happens? The direction of the force and cart they are same. Okay.
Okay.
So read this definition again. You will get this. Read the definition of pull force.
When we apply force in a direction towards us, we are pulling the object towards us, and such a force is called pulling force. Okay, sir. Got
Such a force is called pulling force. Okay. Now, important thing which I just told you that what happens in a pulling force, both the direction of the force and movement is in same direction, which I
Yes, sir.
just discussed. Okay. What are the some examples of pulling force? Like pulling the ropes in a tug of war.
Hmm.
You know what is a tug of war? When two
Yes,
group
sir.
of
Yes, sir.
people
Two
pull a rope.
teams are pulling a rope towards the
Yeah.
line.
So whichever team will have higher magnitude of force, they will be the winner. They will win.
Yes, sir.
Another example is force of gravity. So you know
Okay.
what is gravity? What is force of gravity?
Yes, sir.
It is the force which every object present on Earth experiences. It is basically
Yes.
the force which an object experiences, and it is towards the center of the earth. So
Yes,
basically
sir.
the earth is
We
pulling
don't
all
have
the objects over it towards its center. That
and
is gravity.
we don't have gravity, we will float with.
Exactly. Another example is lifting a bucket filled with water. Here's a bucket filled with water. You're trying to lift it upward, and the motion of the bucket is also upward direction.
Yes, sir.
Right. So that's the specific feature of a pull force, at both the movement of the body and the direction of the force, they both are in the same direction. That is, here in the case of a bucket filled with water, it is upward.
Yes, sir.
Okay. Now, important point to note over here is that when to push or pull force works in the same direction, they are added together. Okay. Let's say there are two persons over here. Person one, can you see the figure? Person one, he is applying force F1. There's
Okay.
another person, and person two, he is applying force F2. So this is
Okay.
basically a piece of stone. So they are applying a push force or a pull force. In this case, they are pushing it.
Yes,
They
sir.
are pushing it. So the net force, the total force acting on this piece of stone will be the sum of the forces applied by both of them. Any confusion in this?
Yes, sir. A bit.
Look, this person F1, this person 1, let's say we said we are representing force by F1 here. Since
Okay.
person, we are representing it by person 1, so we call it F1 force by applied by the person 1.
Okay.
There's another person who applied force F2, person 2, so we call the force F2.
Okay.
Okay, so what happens here? In further classes, you will study that the unit of force is Newton. It's Newton.
Yes, sir.
So we
Yes.
call it 10 Newton. Another person
Mm.
applied 15 Newton of force. So in total, how many newtons of force is acting on this stone? That is quite simple. You can tell that.
25.
25, we are simply adding them, right? So this is the important thing which I was talking about. So that's an important point you should note, that when to push or pull force works in the same direction. Remember the important point, both the forces should be working in the same direction. Then they will
Yes.
be added together.
Okay.
So no matter whether the forces are of push force or pull force, even if two persons tied rope to this stone and they both started pulling it separately,
Okay.
this person applied force F1, this person applied force F2. In this case also, the nature of the force has changed. It is a pull force, right? In the first case, it is push force. So in the case of pull force also, both of them will be added, F1 plus F2. Suppose they are applying 10 Newton, this person 15 Newton. So here
Okay.
also, the total force will be 25 Newton. By magnitude of 25 Newton, this stone is being pulled together by the two persons.
Okay.
Got it so far?
Yes, sir.
Okay, very good. So we are good to move ahead. So if two force, that is push or pull, act in opposite direction, then what will happen? They will be subtracted. That is the net force. What do I mean by net force? Net force is basically total force, sum of all the forces acting on a body.
Okay.
Okay. So the net force working on the body is the difference between the two. Let's say there are two girls over here.
Okay.
Okay. This is Sunita. Okay. This is let's say Fatima.
Oh.
Okay. And let's say this is a piece of wood. This is a piece of wood. So they both are pushing it against each other. Look, she is applying force in this direction,
Okay.
and Fatima is applying force on this wood in this direction.
Okay.
And in this case, I have taken a special case. I have mentioned here that the magnitude of F1 is greater than F2. The force applied by Sunita is greater than force applied by Fatima.
Okay.
So in which direction the wood will move?
Sir, in the direction of Fatima.
In the direction of Fatima. Right. So that since the magnitude of F1 is greater, or we can say it is 25 Newton, while the force applied by Fatima was of
Sir,
only 15 Newton.
sir, magnitude basically means the total pressure. You mean?
No, magnitude simply means the value of something.
Oh, okay.
Okay, magnitude simply it means the value. Okay. Value what? The size of the force. Okay. Something in mathematical terms, we assign values to units.
Okay.
We assign values to whatever the whether it be energy or whether it be some masses or matter, we assign some unit to it. We
Okay.
never say so and so amount of rock, so and so amount of wheat or flour. We say 1 kg of wheat. We say 10 gram of wheat, right? So this is basically magnitude.
Okay.
Okay, so the direction of the movement of the wood is going to be towards Fatima.
Fatima.
Okay, so here the net force will be what? F1 minus F2. So we can calculate it. Here the force applied by Sunita was 25, and that is F1.
Okay.
25 Newton. Force applied by Fatima was
Force applied by Fatima was 15 Newton.
15 Newton. So the net force is going to be 10 Newton,
10 Newton.
right?
Yes, sir.
Okay. So the direction of movement is towards Fatima, and the net force acting will be the difference of the two forces, that is 10 Newton in this case.
Okay.
Okay. Okay then. Now let's talk about magnitude and direction of force. Okay. So magnitude, which I just discussed, that magnitude refers to the size of the force. It is the sum of all the forces acting on a body. So
Okay.
here, this wood was experiencing how many forces? The total force acting in it were two.
25. Okay.
There were two forces acting on it, but
Yes,
the
sir.
magnitude of the total force was of 10 Newton.
Okay.
Got it? So that we refer to as magnitude. That is all the sum of all the forces that acts on a body. Like in the case over here, see, this person is cycling.
Okay.
Okay. So while cycling, you must have experienced that if the weather is windy, you might be experiencing air resistance,
Yes, sir.
right? And if the road is not is smooth, you might be experiencing friction also. Okay. You know what is friction? When two
Uh,
objects are rubbed against
two
each other.
objects. Yes, sir. Two objects together rub with each other is called.
That is called friction. The force generated between the rubbing of by rubbing of the two objects, that is called frictional force.
Yes, sir.
Okay. So this person is at the given time he's experiencing three different types of forces. What are they?
Sir, friction,
Okay, friction.
air
First one,
resistance, air resistance,
air resistance
and gravity.
and gravity. Very good. So gravity is basically pull by the earth. It is the pulling force by earth. Right.
Yes, sir. Right.
Pulling force by earth. So here in this case, what will we say? What is the magnitude of the force? Force of air resistance plus frictional force plus gravity. So
Yes,
that
sir.
is the magnitude of the force acting on this person who is cycling.
Okay.
Okay. So what happens? So when a person is riding a cycle, he experiences multiple forces from different directions.
Okay.
Okay, got it?
Yes, sir.
Okay. Now, You see, the direction towards which the force is applied is known as the direction of the force. Okay. So here the force is being applied in three directions, right?
Yes.
Opposite to the motion of the body, opposite to the motion of the cycle, air resistance is acting.
Sir, what is air resistance?
Air resistance is basically force being exerted by the wind. It is wind basically.
Okay.
If the weather is windy, air resistance will be observed by the person.
Okay.
Okay. So this person is moving in this direction while the direction of this air resistance is opposite in this direction.
Yes, sir. So,
Got
sir,
it?
uh,
Yeah.
so sir, will it be a little bit harder for him to ride the cycle? Will he need more
Yeah,
pressure
exactly.
on the paddles to
He,
move further?
yeah,
Because he is going
yeah,
in the opposite direction. Then he would have to apply less pressure, right?
exactly. That is the case. So if the weather is windy and the wheels of his bicycle are not good enough or the road is very rough, so these are the forces that will determine his speed. If the
Yes,
road is smooth, the wheels are good, and there is no much air resistance, the person will ride fast.
yes, sir, right.
Okay.
Yes,
Now let's talk about forces due to interaction. Okay. So previously I talked about that all life forms or all the phenomena which we observe around us, no matter how tiny it is, everything involves some sort of force.
okay,
Okay. The energy for the forces might be different. The source of energy, like our body, in our body also, everything is happening via force only,
okay,
like the pumping of the blood from the heart, like the pumping of the blood from the heart, that is a force. The blood pushes the blood into the veins and the blood capillaries, right? What is our
yes,
heart doing basically? Our heart, so this is heart, it is pumping blood into all direction.
yes, sir, right.
Some sort of force is acting there. If you
Yes,
place your hand over your chest, you will observe a bulbing force.
yes,
Okay, you will observe the throbbing of the heart. Got it?
okay,
So basically, in nature, there are some other forces also,
okay,
like the gravitational force or
okay,
the force between two charged particles, or how two magnets stick to each other.
okay,
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 so
sir.
you see, if you push someone, if you push a car, push a cycle, or do anything where you
Okay,
are touching the object,
okay,
where you are in touch with the object, you are interacting with the object.
yes, sir.
Basically, the two objects are in contact. The
Yes,
force acting in that case is called contact force. So what do we observe from the first figure? This one.
sir.
Hello. Abu, you aren't audible. Hello. Hello.
Sir, am I audible?
Yeah, now you're audible. Yes, you were saying something.
No, sir. I wasn't saying.
Okay. So you see, forces due to
Okay.
interaction. Interaction is basically what? When two objects come in contact
Yes,
together.
sir.
Okay. So what happens? Interaction can also be of two types. Okay. One where the contact is visible. That is
Okay.
called physical interaction,
Yes, sir.
where we can see that two objects have touched each other. They are in contact. Okay.
Okay.
While they, in some cases, like a bird flying in the air is also
Okay.
experiencing force of gravity, but
Yes, sir.
are they in contact? is the earth and bird in contact, yet the force
No.
of gravity is acting on the bird.
No.
So that is non-physical interaction. That is called
Oh,
also called non-contact forces.
okay.
Okay. So observe the two figures over here and what do you understand from them? Observe the two figures given here and what do you understand from them?
So the first contact force, the contact is happening physically,
Yeah,
and on the second one, uh, it is not
it is the objects are not in touch.
not in touch.
Okay.
Yes.
So in the first figure, we see that this boy and girl are pushing this cart over which a girl is sitting.
Yes, right.
Okay.
Yes.
So that is an example of a contact force.
Oh,
Another figure you will see a lady is pushing a baby cart. That is
yes, sir.
also an example of what?
Yes.
Contact force.
Contact
Carting,
force.
that is also an
Contact
example
force.
of contact force. So a force that is exerted only when two objects are touching each other. That type of
Oh,
force is called contact force. Now moving on to next thing that is non-contact force.
okay.
Like if you throw a ball in the air, it will eventually come back to the ground. Now
Yes,
question
sir.
comes, why it didn't remain suspended in the air?
Okay.
The reason behind this, we all know basically that force of gravity is acting on every object present on Earth,
Yes, sir.
right?
Yes.
So this force of gravity acts downwards. Downwards where? Towards the center of Earth.
Okay.
That is core of Earth. So basically Earth is trying to attract all the objects towards its center. Yet the magnitude of this force is so weak which that we do not experience it. Right. While if you were to go to another planet where this force of gravity is so high in comparison to the force of gravity which we experience on Earth, that the person's body will almost crumble. The person will die immediately because of high force of gravity.
Okay.
Like in the case of what do you say, bigger planets like Jupiter, yeah, Saturn, Uranus, there the force of gravity is so high. Remember, this force of gravity is exerted by almost every planet. Okay. Okay, bro, are you
Sir,
getting
I
it?
did not guess this gravitational force. Uh,
Look, it is nothing. It's not a complex thing to get confused about. Okay. I was just saying that let's say this is Earth. This is the center of the Earth. An object present over the surface of the Earth, he
okay.
will experience a force towards the center of the Earth. That force is called force of gravity.
Okay.
Okay, and because of this force of gravity only, we are able to stand on the Earth.
Okay.
Okay, bro.
Okay.
No confusion?
No, sir.
Okay, good. Now, what happens? During winters, you might have seen that when you take off the sweater, you will experience some charge developing between the skin and the sweater. You might have heard sound of church, kind of something like this.
Or, sir, when you touch someone during winters, you get a little bit of sparkling, or you get a shock of little bit. Are you saying okay?
Yeah. Or
Yes.
also, what happens if you rub a comb over your hair? Let's say you
Okay.
rub a comb over your hair
Okay.
and you bring the comb close to tiny pieces of paper. The papers will stick to the comb.
Yes,
There,
sir.
what is happening? Both the bodies have developed charged on them. The comb and the paper, they have charge on them. Okay. So you know that charged particles attract each other.
Okay.
Okay. So another example of non-contact force is electric force. That that happens when there are two charged bodies.
Okay.
Like in the figure, you can see there are two bodies, this one and this one, and they both have charge on them.
Okay.
And due to this, they might be attracting each other.
Okay.
So another example is electrical force.
Okay.
Okay. You will study about them in higher class. Okay.
Okay.
Now, next interesting force is magnetic force. Okay.
Magnetic. Okay.
Magnetic force, which acts between two magnets.
Yeah.
Okay. So if you bring two magnets together, let's say this is north pole, this one is also north pole. You know, a magnet has got two poles, a north and
Yes,
south
sir.
pole. You know this?
Yes, sir.
Okay. So when we bring the same poles towards each other, they repel each other, right?
Yes.
When the same poles of the magnet are brought together, they repel each other.
Yes, sir.
Okay. And what happens if I bring the north and south pole together, then what will happen? You tell me this. What will happen if I bring the north pole and south pole of a magnet together? These are two magnets over here.
Okay.
What will happen in this case? Will they still repel or will they attract?
They will attack, sir, because some
They
and
will attract.
they are different, right? So that's it.
Yeah. So different poles or unlike poles, different poles, they attract, while the same poles repel each other.
Yes, sir.
Okay. Yet in the first case here, we saw that the objects are not in contact.
Okay.
Here also initially they were not in contact,
Yes, sir.
but there was some force acting which brought them close together and they
Yes.
became in touch.
Yes.
Okay.
Okay.
So I guess this much is enough for today. This much of discussion. We have almost covered the
Okay.
force part. Okay.
Yes.
Everything basically which you had to study about force in this chapter, that is clear.
Okay.
Okay. So do you have
Yes.
any confusion in the chapter? Please do ask.
No, sir.
Okay. So in next class, we will be beginning with pressure. Okay.
Okay.
Which pressure? Exam pressure or this pressure?
Okay.
Okay, okay. The class is not ending yet. I have got
Yes,
few
sir.
questions for you. Let me just a minute.
Okay.
Okay, let me get some space. Okay. So give me two examples of contact forces. Give
Sir,
me
of
contact forces. Give
contact
me two
forces
examples of it.
examples, right? Sir?
Yeah, examples.
Uh.
You think of it, let me write another questions.
Okay. Sir, will pushing a car count as contact forces?
Yeah, that will be counted.
Okay. North pole of a magnet will attract. Sir, the second one is south pole, I think, sir. North
That
pole
is
of will
South
attract
Pole.
south pole. Yes.
Very good. I told you to give two examples of contact forces. You have
Oh, okay,
listed
okay.
only one.
Uh, one is south pole and sir, moving a cupboard or
Moving a cupboard.
yes, sir, moving cupboard, moving chair.
Okay, these are the general examples. Okay,
Okay.
okay. So let's say there's a blacksmith. You know who's a blacksmith?
Black.
Blacksmith. Like they are goldsmiths, they are blacksmiths who heats the iron objects, who heats the iron and molds it into different shapes. That is called a blacksmith.
Oh, yes, sir. Yes, sir. Okay,
In
okay.
Hindi,
Yes, sir.
in Urdu we call them luhar.
Okay. So, sir, they first they heat up the metal and then give them shapes, right?
Yeah, that person is called a
Okay,
blacksmith.
sir.
So let's say there's a blacksmith who hammers a hot piece of iron while making a
Okay.
tool. He
Okay.
is basically hammering a hot piece of iron while making a tool. So in this case, how does the force due to hammering affect the piece of iron? How does hammering this piece of iron will affect its shape? How it is going to affect this piece of iron? Is continuously hammering this
Yes, sir.
and heating also.
Okay.
What is
Sir,
going to
the
happen to
pressure,
this iron?
pressure.
No, my question to you is that here there's a blacksmith who is hammering a hot piece of iron while he is trying
Okay.
to make a tool. Now
Okay.
the question to you is that how does this force, which is due to hammering, affects the piece of this iron?
Sir, because I guess the continuous and lot of weight of this, lot of weight of it.
No, you are not getting my question. My question to you is that upon hammering and heating this piece of iron, what are the changes this piece of iron will undergo?
Sir, the changes of its shapes.
Its shape, that is obvious. That's what I'm asking.
Okay.
The
Okay.
shape of it is going to change. Okay. And the blacksmith will be able to get a desirable shape.
Okay.
Okay. Okay. Okay. Now another question to you is that write it. So there's an inflated balloon.
Okay.
Inflated balloon. You know what is an inflated balloon? A
Yes, sir.
balloon
Yes, sir.
filled with air.
Filled with air.
Okay. So it was basically pressed after a wall.
Okay.
Okay. So an inflated balloon was pressed against a wall after it has been rubbed with a piece of synthetic cloth. So first we rub this inflated balloon with a piece of synthetic cloth. There's a
Okay.
synthetic piece of cloth. We
Mhm.
rubbed it. And now we are trying to press this balloon against a wall. Okay. It was
Okay.
found that the balloon sticks to the wall. What force might be responsible for the attraction
Elect
between the balloon and the wall?
electrical forces.
That is electrical
Electrical
force.
force. Because
Electrical force.
two of the objects are charged, right?
Exactly. And in further classes, you will get to know that the force between two charged particles, that is called in science term, it is called electrostatic force.
Electrostatic
Electrostatic force.
force.
Now, electro, it is connected to charge.
Okay. Yes,
Okay.
sir.
Static, something which is in rest, right?
Okay.
You said
Okay.
that thing is static. The wall
Okay.
is static. The
Yes, sir.
building
Yes,
is static. They are not moving on its own.
yes, sir.
So this balloon and this wall, they are static objects. They are not moving
Okay.
on its own.
Okay.
Yet there's a force acting between them because of charge.
Okay.
Because of charge, there's a force acting between them.
Okay.
Yet both the objects are at rest. So the force
Okay.
between them, which is due to charge, that force is called electrostatic force. I hope it's clear.
Yes, sir.
Okay. Okay. Now name the force acting on a plastic bucket containing water, which is held above ground level in your hand. Discuss why the I'm quoting this question from NCERT.
Okay.
Okay. If you are having difficulty in understanding, you might refer to question number 7 from your text, from your chapter.
Okay. Yes.
Question number 8 actually.
Okay. Question number 8. Name the force acting on traffic bucket ground level and sir, lifting force, right? It is.
Yeah, so we are lifting it. So
Yes, sir.
here the muscular force is happening.
Okay, okay.
The person is applying muscular force in
Question.
lifting the bucket.
Okay, sir.
Okay.
Okay.
What does the next part of the question say? The next part of the question says,
Yes, sir.
discuss why the force acting on the bucket do not bring a change in its state of motion. So that's an
Yes.
interesting question. Think of it.
Yes, discuss why the forces acting on the bucket do not bring in bring a change in state of flow. Sir, is it asking me why the shape of it does not change or the motion of it
No,
does not?
no, the position of it in its state of in its state of motion.
Oh, so sir, because state of
Look, at any given time,
okay,
an object will basically experiencing two or three or multiple forces.
okay,
So out of the all forces acting on an object, one force that will always act, that will be force of gravity, which you forget
okay,
about.
okay,
Force of gravity.
okay,
So here, a boy is pulling this bucket upward.
okay,
So he is applying muscular force. Muscular
okay,
force, why? Because it is being applied by person where he is using basically his muscles to lift the bucket.
okay, sir.
There's one more force acting on it, that is force of gravity.
Okay, okay, sir.
Force of gravity.
Okay,
Okay. And the question says that name the force acting on a plastic bucket containing water held above ground level in your hand. Okay. So the
okay,
what are the forces? The forces are muscular force and force of gravity. We have
okay.
listed them.
Yes, sir.
Now, if you read question carefully, the question says that it is being held above ground level in your hand. The boy is basically holding this piece of bucket filled water on his hand with his hand. Okay, so this bucket is being held by this boy. Okay, he is not
Yeah.
dropping it. He is not raising it upper. He has just
Okay,
he is just holding it like this. He is just holding it like this. Okay. So why there's no further change in its state of motion? Because there's force of gravity acting downward also. That's why it remains same. So what happens? Let me clarify for you. The force here, what is happening? Force of
okay,
gravity. In this case, it is equal to force applied by this boy.
okay,
What is happening? The muscular force and force of gravity both are same in size. That's
okay,
why in this case, that's why the position of the bucket, its state of motion is not changing further.
okay,
Okay,
okay, sir.
so basically the two forces are equal here in magnitude.
Okay,
Okay,
yes, sir.
got it or any confusion?
No, sir, got it. Okay.
Okay, okay, very good. Okay, so far any confusion what we have just
No, sir.
discussed?
No, sir. No, sir. I'm all clear.
Okay, very good. Okay, so since we have few minutes left, let's discuss a bit about pressure also. Okay,
Okay, sir.
so what happens in the pressure? Like we measure BP, that is blood pressure.
Blood pressure.
We measure blood pressure. We measure blood pressure. So basically, while we are measuring the blood pressure, we are actually measuring the force by which the heart is pumping blood to all parts of the body.
Okay.
This let's say this is a heart. Okay, a rough diagram of a heart. So this heart is applying a push force. Okay, and it is applying the push force, and the blood is being transported to all parts of the body. So the magnitude of that force we call as blood pressure. Okay.
Okay.
So in physics, when you talk about blood pressure, it will be better to refer to the diagram, to the image second and third. Okay.
Okay.
So I just gave you an idea of what are we actually measuring in blood pressure. We are actually measuring the push force that is being applied by the heart. So that is generally blood pressure.
Okay.
Okay. So pressure, what happens when a force is acting over a unit area or over a given area, that is called pressure. Here you see this stone is applying a downward force, right?
Okay.
Any object which has got mass, which is heavy, it will apply a force downward,
Yes, sir.
right? So upon this much area of this person, you will see this stone is applying force in downward direction.
Yes, sir.
So there's a given area over which this force is acting.
Okay.
So look at the next figure. Here, a force is acting over a given unit area. Let's consider this to be a cylinder. Let's
Yeah.
consider this to be a piece of cylinder,
Okay.
LPG cylinder, which we use at our homes.
Okay, sir.
So at its base, the whole body must be applying some force. The area is fixed over which this force is being applied.
Okay.
So pressure is basically defined by force acting over an area. Force acting
Okay.
over
Over it
a over a given area.
area.
It's better to call over a given unit area.
Okay.
A given unit area is called pressure. Is called pressure. Okay.